In this video, I'm going to look at an R program that's going to read in a poem from a text file and then sort of perform a letter frequency. How many times does a letter A appear in it, and B, etc., and then use that to calculate the letter entropy, but mainly just an example of some R programming. Okay, so I want to read. Often in R, you're reading like data files, and this is just a plain old text file, and I want to read it all at once. So got this from Geeks for Geeks, and they use read file, and they use the library reader. So I read in the file. So I needed the path of the file. So I sort of right-clicked on the file and went to its properties, and here was the location that gave me the folder, and it has the sort of a backslash, and I needed to turn those into forward slashes. So I just had to like copy this and then go in and change the order of the slashes, and then I needed the name of the file. So that's what I did here. And then I read in the file. It's got lots of weird, all sorts of weird tabs, because the people who I took this off the internet, and he had some weird indenting in the original publication, and they like to respect that. Okay. And then I lost, oh, there it is. I'm going to sort of analyze how many times the letters appear. And I always pick the bells because it repeats the word bell so often. I want to see if it can throw it off, but it doesn't really. But I want to point out here that there is this word with, I'm going to call it a diphthong, but it's also a ligature. And so in printing, sometimes they slap two letters together to make one letter, and I am going to lose that letter. So it's not as accurate as it could be, because I'm not dealing with the ligature. I'll point out when that happens. Okay. All right, so at this stage, we have read the file, and there's the program. So this is a /r and /n are like returns and new lines. Okay, and they're probably, I went along in there, probably some tabs and so on, but okay. But so I've read in the poem, and now I'm going to, you see here that it's capital T and capital B. I'm going to use the to_lower function to make all those lower cases. So I'm not going to make any distinction between capital T's and lowercase t's. I want to just run this. Okay, so now I've redefined bells with all lowercase letters. And the next thing I want to do is, I'm only interested in letters, and this is where I'm going to get rid of my ligatures or diphthongs or whatever it was. And I'm just going to keep the regular letters from A to Z. And so I'm using the G sub method for that. So I'm looking for a regular expression, and I'm looking, square bracket is a set of things, and I am the caret. In a regular expression, caret at the beginning can mean that you want the pattern to be at the beginning. But if you have a caret inside a set, inside a square bracket, then it means not. So I'm looking for anything that's not a letter from A to Z, and I'm going to replace that with nothing. And I'm going to make that, so I'm looking for anything that's not a letter, replacing it with nothing inside bells and make it the new bells. So I'll get rid of all of these. I'll get rid of the space. I'll get rid of the return and the new line characters. There we go. So it's just letters now. Okay. Now I want to find the overall number of letters. So I'm using the NCAR. And so there are 2,596 letters in there, all and that poem, just letters. And again, I've gotten rid of those literatures. Okay, now I want to count the frequencies. I want to say how many times I got an A, how many times I got a B, etc. And so I'm just preparing space for that. I'm making an empty vector. So you'll just see pop over here in the environment sort of an empty vector after I run that. So I have a frequency with nothing in it at this stage. Okay. I'm going to loop over the letters, A, B, C, D, and I grabbed from this reference, from this URL, I found they told me a way to sort of easily get the letters, a range of letters. So there was a predefined thing, letters, and here's the range of letters, 1 to 26. So that creates for me a range of letters, and then I'm looping over. So I'm getting a letter in the set of letters and looping through that. So each iteration is one letter, A, then B, then C, etc. I am again measuring the length of bells, and I'm calling that before. And then I'm going to do another G sub, and this time I'm going to look for that letter that is the current iteration's letter and replace it with nothing. And then I'm going to measure the length after. And so the length before minus the length after, that's going to be how many times it found that letter. That's going to be what I'm going to call my frequency. And I'm going to append to my frequency vector this difference of the before minus the after and add it to my frequency vector. So here in this loop, again, I'm looping over the letters, measuring the length at the beginning of the iteration. I am substituting, getting rid of the letter, basically by substituting the letter with nothing. I'm measuring the length after, and then that before minus after, that change is the frequency. So I add that to I'm appending that using append, I'm appending that value to my frequency vector. So let's run that loop. Okay, and so in here I have the frequencies. I had 146 A's and 81 B's and 27 C's, etc. Okay, now I just want to look at that. So I'm going to make a bar graph. Now overall, I am creating sort of a histogram of the letters, but I have done myself the counting. So I can't use the built-in R hist method because then it wants to do its own counting and it will just count how many times my counts occurred. And that's not what I want. So I'm going to make a bar plot and just in my own mind know that it happens to be a histogram. And I'm making a bar plot of the frequencies. I'm going to give it a title. That's main. I know here's E, A, B, C, D, E, and E is usually the most common letter. And that was 341. So I made sort of my y-axis extend from 0 to 350. My labels of my bars, of my columns, are going to again be the letters. So I use that letters range. There's a sort of a standard size for the size of the labels. I want to shrink it to 75% of its normal size, make it a little bit smaller, because it will skip like every other label on me or something if it's taking up too much space. Col is the color, so I'm going to make it dark red. And LAS is like the orientation. So there are different numbers, and I can I'm just going to write it vertically, I believe. So this is my bar plot. Let's run that. And there is my bar plot showing the letters and how often they occurred. Okay. Now I'm going to calculate an entropy based on these occurrences. And so the entropy is the sum of p log base 2 of p, where p is a probability. So I'm going to turn these frequencies into a quote unquote probability by, say, dividing the frequency by the total number of letters. So I'm going to say then that is the probability of the letter occurring within this text. And then I am going to loop over all my letters, find their probabilities, and then add negative p log p to create the entropy. Okay, and I can't do this if the frequency is 0. So if I had a short enough text or some unusual text and we see here, I had very few J's and Q's and X's and Z's, but I did have a little bit. So I didn't really need this if, but for normal text, there might possibly be letters that don't appear, and I don't want to try to take the logarithm of a 0. That would be make the program blow up. So I'm looping over my frequency array. I'll call an individual frequency an element of this vector. I should call it a vector if I'm doing R. An element of this vector I'm calling F. If F is not equal to 0, I'm calculating the probability P by taking the frequency and dividing it by the total number of letters. And then I'm taking whatever entropy I have so far and subtracting P times log 2. That for information entropy, you use log base 2 because that's 2 corresponds to a bit. Has 2 possibilities, sort of 0 and 1, high and low, whatever you want to call it. So P log base 2 of P, add those all up in that, and I will calculate an entropy. We'll just see it over here in the environment. And I also calculated the capacity. There were 26 letters, and that would be what is my capability of transferring information sort of per letter. And then here's what I actually did based on my letter frequencies. So up here we see that my entropy, the amount of information I'm conveying sort of per letter, is about 4 bits, a little over 4 bits. And I had the capacity to convey, with just 26 letters, 4.7 bits. So I wasn't reaching my capacity, but just having certain letters occur more often than others means, and we use a lot of vowels, of course, then that reduces our entropy compared to what we could convey. All right, that's what I wanted to show you, just a little bit of, I don't know, fun with R. Thanks for your attention.